On this second video, we are going to move on to the output part of this session. And after this session, you should be able to explain the basic schematics for output ports, to relate the output interface with its operating mode, and also to explain the output timings and operations. During an output operation, the content of any of the 16 data registers inside the PicoBlaze is going to be presented in the out port. The port ID is defined by a register or a constant, and selects the desired output destination, which means is going to decide where the output data is going to. And the right strobe output pulse is asserted high on the second clock of the 2-clock cycle instruction, and indicates that the data on the out port is now valid and ready to be captured. So the right strobe combined with a port ID signal are used as a clock enable on the FPGA logic that captures the output data from the out port. Now we're going to analyze the instructions and the time charts for output operations. The output instructions that writes data on the out port can be these two right here. On the first one, the port ID is stored in a register, the SY register in this case. And on the second one, the port ID is specified by a port name that normally is a 2 hexadecimal digit number, as we are going to see on the example on the figure. So in this example, the PicoBlaze microcontroller writes the content of the register S0 on the hexadecimal port number 65, which is specified by the port ID signal. The content of the register S0 is going to appear on the out port, and once again the right strobe signal goes high on the second clock of the 2-clock cycle instructions, indicating that the data is valid. On the third clock cycle, which is the number 2 here on the figure, the data it's not anymore on the PicoBlaze microcontroller, and it's now on the FPGA register. And now we're going to analyze an output interface with more than one output port. On the slide number 3, we looked at an output interface with only one output port. So this interface consists of a decoding circuit and some necessary output buffers, which normally are an array of registers. So this decoding circuit decodes the port ID and generates an enable ticking accordingly to what was decoded. It means that which buffer is going to store the data. These buffers can be distinguished from each other with only 2 less significant bits. And the enable ticks are going to activate the corresponding output register to retrieve the data from the out port. On the second clock cycle of any output instruction, the right strobe signal is asserted high, and 1 bit of this 4-bit enable_d signal is asserted accordingly. Then on the rising edge of the third clock cycle, the data value on the out port is finally going to be stored on the corresponding buffer. Here are some lecture sources for further information.